In this video we have a 2x2 determinant and a 3x3 determinant, and we're given the value of each of these and we want to find the value of x. So we have one unknown component in this first 2x2 determinant. So the procedure for evaluating a 2x2 is to cross multiply. So it's 3 times negative 2 is negative 6, and then we subtract the product the other way. So 2 times x will give us 2x, and we know the value of that is negative 20. So that generates a linear equation here. We just solve for x. So we add 6 to both sides here to isolate the term with the x. Add 6 here. Those cancel out. We get a minus 2x. Then negative 20 and 6 is a negative 14. We divide both sides by a negative 2. This cancels out here. Negative 14 divided by negative 2 is 7. So the value of the x for the first determinant is 7. Now for the second one, similar problem, except now it's a 3x3 for the determinant, and we know the value is negative 112, and we have again one value that's unknown, that's the x, that's worth trying to find. So we do the same thing. We take the determinant, evaluate it. We can use the cofactors and minors. We can use properties of determinants, and we know the value of that is going to be negative 112. So I've gone over several methods for evaluating 3x3s. For this one here, I'm going to use what is called sometimes the column method here. So I got the determinant negative 1, 2x, 5, 0, negative 2, 1, negative 1, 9. Again, you can use any row, any column, and expand the determinant using cofactors and minors. But for the column method, what we do is we take the first two columns and write them out to the right. So column 1 is negative 1, 5, 1. Column 2 is 2, 0, negative 1. And then the procedure is we start in this corner right here, and we just multiply down the diagonal. So it's negative 1 times 0 times negative 9, but we have a 0 there, so that's going to give me 0. And then we add these products. So the next one would be 2 times negative 2 times 1, that's negative 4. And then the next one, again, we're adding these right here, x times 5 times negative 1, that'll be a negative 5x. Then we start at this corner here, and we multiply up the diagonals this way. And these are going to be subtracted. So I'll put a minus there, and again we go 1 times 0 times x. Well, it doesn't matter because you have a factor. One factor is 0, so the whole thing is 0. So this will be 0 here. And then it's minus, with the next one, negative 1 times a negative 2 is a positive 2, and then a negative gives me a negative 2. And then the next one will be 9 this way. 9 times 5 is 45, then 2 will give me 90. Get that. So then we have a negative 4 here and a negative 2, and there's a minus here. So this will be negative 4, and a plus 2 will give me a negative 2. And we have a minus 90. We have a minus 5x. So again, minus 4, and a plus 2 here is a minus 2. And then we have a minus 90. Then we have minus 5x. This would be the value of the determinant, and that's given to be a negative 112. So this would be a minus 5x here. It's going to equal to, and then this is a minus 2 here, minus 92 here. Add that to both sides, so a plus 92 and a minus 112 will give us a negative 20. Adding positive 92 to both sides, we get this, divide by negative 5 here, This cancels out. Negative 20 divided by negative 5 is a positive 4. And that's the solution for this one. Thanks for watching. We'll see you next time.